number one said the mean outstanding credit card debt of a college undergrad was $3,173 in 2010. A researcher believes the amount has decreased. So what would the null hypothesis be? Mean equals 3173. I had some people asking, does it matter if I put X bar or if I put mu? I don't care. Both means, so I'm not going to count off on that. And then we believe it's decreased, so that would be less than. So B, type 1. Remember, in type 1, you conclude H1. The ones go together, but it's an error. So it would be if we conclude has decreased or is less than the 3173, but it has not. It's an error, so we made the wrong conclusion.
If we were to say because the alternate hypothesis,
That's fine.
you don't have to say what it means.
Yeah, that would be fine. Type 2 error is when we conclude H sub 0. So concluding the mean is the $3,173, but we are wrong. We should have gone with the other one. So, but it has decreased. Or, but we are wrong. Why would I say decreased and not increased?
Because we're checking to see if it decreased.
Yeah, we're checking the alternative was decreased. Okay, so in these questions, like type 1, type 2 error, you just basically need to tell me which one you concluded and that you're wrong in those. They're errors, so we made a mistake. D, the conclusion if the null is not rejected. And that doesn't mean just say fail to reject. This is, tell me that sentence. So if we do not reject it, does that mean we proved this was true? No. It just means there is not enough evidence to conclude the mean has decreased.
Can I say there is evidence to conclude the mean debt hasn't changed?
We're not proving this. We're trying to prove the other one. So if we fail to reject it, just means I couldn't prove this was right.
What if I didn't have the word enough? I just said there was no evidence.
That would be fine.
Okay.
Then E, the conclusion if the null is rejected. So that means there is sufficient evidence to conclude the mean has decreased, or the mean is less than the 3,170. Okay, these are not your conclusions. This is not something that you are trying to mimic me word for word. You don't have to have exactly what I say, but you need this gist. Make sure you realize if we fail to reject, that we are never proving the null hypothesis is true. We just couldn't prove it was false. Okay, so we either have enough evidence to prove the null hypothesis or the alternative hypothesis is true, or we don't. That's our scenario. Is that okay with everyone? Number 2. So the proportion, as soon as I see proportion, what does that tell me my variable is? P. So the proportion of individuals who cover their mouths when sneezing is 0.733. So the null is that the proportion is 0.733. The alternative hypothesis, the student believes the proportion is different. So different means not equal. So that's part A. All right, verify the conditions for a normal model. So as we go through this,
Was that the whole marker?
that was the entire marker. That was interesting. Okay.
You just popped them back.
Yeah,
some more.
that was
You have to-
very
you have
violent
to
when I
factor
opened
in
the marker.
shipping.
I guess that was my fault, man. I was the last one to use that marker.
Yeah, what did you do to my marker?
I opened it.
Let's refresh our criteria. If we're looking at P, we have different criteria, but all I'm really wondering, because all I really ever give you the information to prove in this is what?
Greater than
Times
30.
P,
You're right.
1 minus P is greater than 10.
Uh-huh. If I'm talking about the mean, my criteria is either in,
It's greater than 30 or it says no.
right.
I did not do it right.
Okay. So my criteria here, we're talking about P, so I'm doing my N. How many did I observe?
78 over 100.
So my N was 100. My P is the 0.733, the P from the null hypothesis. Okay, if you do that, I got 19.577, so that's bigger than 10. Check. If you don't even tell me what it equals, I don't overly care. I need you to show me this bigger than 10. So I know you know what your criteria are and you're checking it. Then part C. I did tell you we don't have to do any of them by hand. I've kind of modified your test. It's strictly calculator. So on your calculator, I'm going to be asking like every question. I went in and added this. Okay, and so I want you to fill in the blanks. So let's all do these on our calculator as we go through. Even if you did it yesterday, it's good practice today. Repetition will get us there. So if we go stat tests, if I am talking about a P, okay, so we need the one proportion Z test, which is number 5. So on your test, I'm asking you to just fill in these blanks and say, okay, stat test number 5. And then it would be helpful if you just wrote out to the side those questions that it asks you. At least like your P, your X, and N, so I know you realize what they were. So the P of the null is 0.733. What's my X?
70.
And my N? So that's kind of the work you are showing me. And we are testing not equal, calculate. So I want you to circle. Is it Z or is it T?
Z.
Z, and my Z is 1.0624, and the probability is 0.2881. And so then our conclusion, I'm really looking for you to just say reject or fail to reject here. So if I look, my P is bigger than my alpha, which means fail to reject. If I wanted an entire sentence explaining it, I would probably add a part D and say, write a sentence explaining this conclusion. And that would be when you say, there is not enough evidence to conclude the proportion is different than 0.733. Is that okay? All right, so problem 3. Professor recommends his students spend 480 minutes outside of class studying each week. The number of minutes each student in a class spent doing an online assignment is recorded. Assume the data is normal. Does the evidence suggest the students are studying less than the recommended? So what is my null hypothesis? And if I put this on the test, I probably would tell you to go ahead and write the null and alternative as well. Am I talking about a mean or a proportion? A mean. Proportion is a decimal between 0 and 1. If I look at my data, that's not what I have. So the null is that the mean is equal to 480. He wants to know if his students are studying less, if the alternative is the mean is less than 480. So you need to go and enter your data into L1. let's all do that. All right. And so then on the test, I would have something like this. Stat test, which one are we going through? So if we are dealing with p's, we know we're always looking for things involving a z. If I'm talking about mean, we're always looking for things involving a t. So the different options, if we're testing a hypothesis, that's when we do number 2, the t-test. We're looking for the interval here. So that was number 8, the t-interval. If I were talking about the p, the proportion, and wanting an interval, which one would you do? Like if I said to build a confidence interval in question number 2. Yep. The 1 proportion z interval. So these are just kind of making a list of the tests that we use. So things involving z, we're always doing the 1 proportion. So 1 proportion z test, 1 proportion z interval. When we're looking at t, we're always talking about t test, t interval. All right. So if we go into number 8, it tells us data. So make sure your list is L1. So on my test, I would fill in the blank here and say this is 8. There's not a lot to put in here. Our confidence level is what?
We're on 3, we're not doing number.
Oh, shoot. Sorry.
We're doing number 2.
In my mind, I was doing a confidence interval. I guess I didn't look at the whole question. Okay. We're just doing the test. So number 2. Test number 2. Okay. We are basing it off data or stats? Data because we have it entered. So mu of the null is 480. List, we have everything in L1. Frequency should never change. It's just 1 we're testing less than. Calculate. And so then I would ask you, is this a z or a t? And what is your probability? So we are doing a t value. We get negative 1.5768. We get our p to be 0.07296. Then our conclusion. P, my alpha was 0.05. So is p bigger or smaller than alpha?
Bigger.
And if p is bigger than alpha, what does that mean? Okay, if I asked for a sentence explaining it, we would say there is not enough evidence to conclude because students are studying less.
Do you want us to write the list L1? Because I wrote the.
You don't necessarily have to.
Okay.
Number 4. To determine if the mean is more than 100. So, what's my null?
100.
Equals 1.
The mean equals 100. The alternative, we want to test if it's
Greater than.
greater than, more than 100. Okay, a sample of 35 is obtained from a distribution. The sample mean is 104.3 and standard deviation is 12.4. So B, what conditions?
Bigger than 30.
So 35 is bigger than 30, so that's good. So I told you you don't have to do this by hand. So again on the test, I'll have stat tests. Tell me which one you use. Is this a Z or a T? Tell me what you get and what's your P. So when I go in stat test, I'm talking about a mean. So I'm doing number 2. Okay, let's write down our information. Do we have data or stats this time? So the mean of the null is 100. What is my X bar?
104.3.
And what is my standard deviation?
12.4.
less than greater than. So I have a t value, 2.0515, and my p is 0.024. So what does that tell me?
P is less than alpha. Reject.
Reject the null hypothesis. There is evidence to conclude the mean is more than 100. Are you guys getting a feel for what work I'm wanting you to show? Number 5. Golf balls are required to have a diameter of 1.68 inches. A random sample of golf balls was collected. The diameters were recorded. Assume the data is normal. Construct a 95% confidence interval to determine if the balls meet specifications. So what would be my null hypothesis?
Equals 1.68.
Okay, is it
Mean.
mean or p?
Mean.
Mean equals 1.68. What about my alternative?
Does not equal.
Right. It has to meet specifications. It can't be bigger, it can't be smaller. So now we go to our calculator and we're going to enter everything into our list. Which test would we go into? Number 8. We want the t interval. Okay, so I am going to base this off data. List is L1, frequency is 1, confidence level is 0.95. So you could write that stuff down. There's not a lot to write down here because it's all based off of data. So I get 1.6782 to 1.683. Is everybody getting these tests to work out? Okay. So now I have to make a conclusion. Do these balls meet the specifications?
We failed reject.
My mean is 1.68. There is a 95% chance the mean is between these numbers. Is 1.68 between them? Yes. So, since mean is in the interval, we fail to reject. The balls meet the specifications.
You can't say that.
We didn't prove that they did. So the question I did ask to determine whether they meet the
Oh.
standards. So I haven't been able to prove that they don't meet the standards. So I did not prove the mean is exactly 1.68, but they fall within the accepted range. All right. Is that one okay? Number 6, the proportion of patients who visit the ER and die within a year is 0.05. Proportion. So what's my variable? So my null is that P is equal to 0.05. Suppose the hospital administrator is concerned his ER has a higher proportion. So that would be greater than. Okay, B, verify the conditions. If I'm talking about a proportion, my conditions are N. What's my N? Times P, which is, and 1 minus P. Okay. And that has to be greater than 10. So you're welcome to write down what that multiplies out to. 11.875, so just barely, but it is bigger than 10, so we can move forward.
How much will you take off if I do the wrong criteria? Like if I think maybe it's supposed to be greater than 30. Just give me a point.
1 to 2 points. So
Do we have to do the n is less than or equal to 0.05?
I'm kind of letting that one go for now, just because on this whole unit, we've never had the information to verify it, so
Okay,
we're
so-
just going to kind of assume that one's met. I really just need you to check this one.
Okay.
Okay, so then we go stat, test, which one am I going to? Okay, then we have to fill in the blanks, and you'll know if you pick the wrong test because you won't be able to fill in the blanks. It'll ask you for things you don't have. The p of the null is 0.05. What are we using for x?
17.
N and we are testing greater than, so we have a z value 1.3059, u is 0.0958. So what's my conclusion?
C is greater than 7.
Fail to conclude. There is not evidence to conclude the rate is higher at his ER. Part D, I'm asking you to do a confidence interval to go along with this. So, which one do we go to for the confidence interval? The one proportion Z interval. Okay, everything is in there already, the X, the N. Confidence level, we need to change to 0.99.
And someone just PR'd.
Let me get this. So that means, I did ask you to interpret on this one. We are 99% confident. The proportion is between 0.0699 and 0.1090. Is this helpful at all?
It is.
Then the next 2 pages, let's switch.
We started going to match pairs.
Yeah, we have 2 samples in all these. So the big things with 2 samples, you have to decide, is this matched pairs or not? So that's what we really have to look at. Now, on 7, I kind of gave you a hint, because I said, why is this matched pairs? So you know it is. A big thing you could look at, also with just looking at that table. When I see student 1, there's 2 different measurements. So those 2 numbers are paired up. They are related to student 1. So that's also a big clue. If I'm giving you the data and it's essentially making an ordered pair, that's matched pairs data. This one, it's because the arm height data came from one person. Okay, I didn't compare Luke's arm span and Tanner's height. I did Luke's arm span to his height and Tanner's arm span to his height. I compared them to each other. So B, the null and alternative hypothesis. Am I talking about mean or proportion? Mean. If it's matched pairs, the null is always what? The difference is 0. So this is what you really need to watch. Make sure you remember. If it's matched pairs, we're assuming no difference. The difference is 0. And we are just trying to see, we're comparing or testing if they are equal. So the alternative would be. All right, then this is when we enter it. And how do we have to enter this? L1, L2. Think of them as ordered pairs, so they do need to line up. They have to go in order. And then what do we do for L3?
L1 minus L2.
So make sure you know how to get all of that data entered. Are you going to get some? Okay. Thank you. So we do our L1, L2, L3 is L1 minus L2. So then we do stat. All right, what test are we going to go to?
T.
So that's really the big difference between independent and dependent. We're just doing a regular t-test here. The mean of the null is 0. My list, which list do you need to use?
3.
And everybody's good with changing your lists? And we're testing not equal, so calculate. So my get a t-value, and it turns out to be negative 0.3924. Our probability is 0.7039. That is extremely high. That means if the null hypothesis is true, there is a 70% chance of the data we got. So that's pretty convincing. Since b is greater than alpha, fails for each. Did I prove they were the same? No, I just couldn't prove they're not.
Wrong the first time, I guess. You got it wrong the first time. I got it right this time. I got my P was 0.0000002855.
Oh, that's very small. You probably left a number in your null hypothesis. In your calculator, you probably didn't change it to 0. Number 8, suppose that independent sampling. I already told you they're independent, so that means they're totally different. What null hypothesis do we do if they're independent?
M1 equal to 2.
Mean first is equal to the mean of second. So dependent, we're assuming the difference is 0. If they're independent, we just assume that the two means are the same. And then we want to test if the first set of data has a higher mean. So if the mean of the first is bigger than the second. All right, so we go into stat test. I am still talking about a t because I'm dealing with the mean, but I now have two sets of data. So what do we go to?
Number 4.
Number 4, 2 sample t-tests. So we're adding another thing. If I'm talking about a t, if I have 2 totally different samples, we do number 4. Okay, and then we are basing ours off stats. So we have to write down. This is the mean of the first, which I told us was 48.2. Standard deviation of the first was 8.4. N of the first was 45. And same thing for the second. What's another huge clue if you just looked at that table that would tell you they have to be independent?
Equal ones.
They have a different sample size.
Yep, different sample sizes. Okay, and we we are testing greater than. Make sure pooled is kept to no. So we get a T of 1.4717, probability 0.0726. So my conclusion, alpha was 0.1, so P is less than alpha. We reject. Okay. Next one. I want the confidence interval for the mean of the first minus the mean of the second. What do we go to? 0. We look 2 sample t interval. Okay. So these are relative twos. So when I look at this, it should have carried over all my numbers for me. You just need to change your confidence level to 0.96. And calculate, we get 1.258 to 7.258. Yes.
When questions like this, do you want us to write all that down, or can we just draw an arrow from there?
Yeah, since I already organized it all in a table, you wouldn't have to. Now, if I gave you like a paragraph where I stated all the numbers, then write them down so I know you put them. Good question. Anything else? Okay.
Do you want us to write something?
For the confidence interval one, you don't really have to. We already tested the hypothesis in part B. So since we already did it in the question, you don't have to again. Number 9 tells us, suppose the following matched pairs data. So what do I need to do? List L1, L2, and then L3 is the difference. So the null, anytime it's matched pairs, null is that the difference is 0. Alternative, we want to determine if the mean of the first group is smaller. If the first group has a smaller mean, what will be true about their difference? Okay, the next question. I asked you to find the mean and standard deviation of that difference. Where can I go to get that? Stat Calc 1 for list 3. And so my X bar is what I wrote as D bar, the mean of the difference. Standard deviation 4502. Are you getting sick?
Yeah, I've been sick for a little while.
It's not getting better.
I feel bad, I just keep coughing. It won't stop for weeks now.
Probably go with that.
I finally got a doctor's appointment for that same issue.
Yeah, I just feel
My-
fine.
My doctor was out of town for like 2 weeks.
So now I asked you to test the hypothesis, so where do we go?
2.
Stat test number 2. Then you have to tell me, is this Z or T? And probability, so those will be all the questions I asked. Stat test number 2, data or stats? Data. Mean of the null is 0, list is L3, we are testing less than, calculate. So we get our T, 0.9068, and our probability, 0.2030. Look below that P. What do you see?
X bar?
X bar, is that the same as we wrote down up here? Yeah. what's the standard deviation below there?
0.4502.
So it actually gives it to us on that screen as well. We just never have used it from there, but just another option. So my conclusion, since my alpha was 0.05, so since p is greater than alpha, what does that mean? Okay. Confidence interval, where do we go?
0.
We don't want a z.
It's 8.
Yeah, we're doing number 8, just the t interval, because
I
we're
got
just doing the one group, the difference. Data is L3, frequency 1, confidence level is 0.98. We get negative 0.7851 and positive 0.451. To be normal. We know we're talking about a mean here. So our criteria, either the same plus be bigger than 30, and it's not, so that means the data has to be normal. Okay, null and alternative. Let's think about that for a second. We have to decide, is this matched pairs or is it not? Okay, matched pairs means I have to be able to put these in some kind of ordered pair. So it would be like, I had a test and Sam studied from the visual manual the first time and the second time from the text manual. Did I tell you that that's what it was here? No, I just have a set of scores from each. So can I pair them up in any way? No, so I need to treat them as two separate groups, so they are independent. So we're testing if the mean of the first is equal to the mean of the second. The alternative, we're seeing if there's a difference, so that would mean what? Not equal. All right. So, before we can test it, we have to enter all of this. So, clear out all your lists and put them in L1 and L2. Which test do we go to? Stat test number 4. When you're basing this off data, list 1 should be L1, list 2 is L2, frequency is both 1. Testing not equal to calculate. So it gives us a t value. And a p. So our conclusion, my alpha was what? So this time p is smaller than alpha, which means reject. Then part D, I asked you to write a sentence explaining that. So we reject, that means there is enough evidence. You could say just the means are different, or you could actually use the information from the problem. There is a difference in comprehension.